Hi there, we're on to our next special numbers lesson now, and we're just going to recap where we got up to. So we've learnt about multiples, common multiples, and lowest common multiples. Remember, we called that LCM for short, lowest common multiple. Then in the last lesson, we've learnt about factors and common factors. What we're going to look at today is highest common factor. Then we're going to go on to looking at prime numbers and prime factors. So we'll see how far we get with that before we get on to this bit at the bottom here about questions in context. So we want to be able to identify and list all of these things that we've been learning about, all to do with multiples, factors and prime numbers. So our recap on factors before we go on and look at highest common factor. So remember, factors are what multiply to make a number, and we list them systematically. We've been learning how to do that in the last lesson. So remember, the systematic way to do it is you write down 1 and the number itself. So we're writing down these factors in pairs. So 1 times 24 is 24. Then we think, does 2 go into 24? Yes, it does. So 2 is a factor of 24, and we write its partner down. 2 times 12 makes 24. Then we think, does 3 go into 24? And it does. So we write down 3, and then we write down the partner of 3 to multiply and make 24. So 3 times 8 is 24. Next, it would be 4. 1, 2, 3, 4. Does 4 go into 24? And it does. And the partner of 4, which is why I said it a moment ago, is 6, because 4 times 6 is 24. So the next number we would try is 5, but 5 doesn't go into 24, so we don't write it down. And then it would be 6, but if we look, we've already got 6, so we know we've got all the factors of 24, and if we list them, we do it in that order. So we do 1, 2, 3, 4, 6, 8, 12 and 24, and we can write that out in a list in order. Apart from anything else, it makes us look like we really know what we're doing when we list them in order. It gives a great impression. Okay, so we're going to do the same for 36. So we start off with 1 and 36. Okay, so we see, does 2 go into 36? And it does. So 2 times 18 is 36. Then does 3 go into 36? And it does. 3 times 12 is 36. And then 4. 4 times 9 is 36. 5. No, 5 doesn't go into 36. 6 does. And it goes 6 times. So once we reach a number that's already in the right-hand column, we stop, because that means we've got all the factors. By doing it this way, we definitely do not miss any out, okay? But when we write them down, 1, 2, 3, 4, 6, we don't write 6 twice, because this is just a list of factors. So we don't bother putting 6 and 6, because we've already said that 6 is a factor. So then 9, 12, 18, and 36. So we've listed all the factors of 24 and all the factors of 36. And now remember, common factors, they're the numbers that are in both lists. So we're going to have a look at these lists now. So 1 is in both lists. 2 is in both lists. 3 and 4 are in both lists. 6 is in both lists. But then 8 is not in both lists, because 8's in that one but not in that one. 12 is in both lists. 24 is not in both lists. So we know we've got them because we've checked whether these numbers are in that list. And we know that these numbers are not in that list because we haven't looked at them. Okay? So the common factors of 24 and 36 are 1, 2, 3, 4, 6 and 12. So it's quite a lot of common factors there, aren't there? And as we looked at in the learning outcomes at the start of the lesson, our next piece of work is to learn about highest common factor. Now, the reason we talk about highest common factor and not lowest common factor is, well, if you think about it, you can probably work it out. If you look at the lists, the lowest common factor is always going to be 1, because remember, these lists always start with 1 and the number itself. So it doesn't make any sense to talk about a lowest common factor because it's always going to be 1. So we talk about the highest common factor because that does make sense. That's the biggest number that can be multiplied to make our two numbers. Okay, so we're going on to look at highest common factor now. And in much the same way as we were looking at common multiples and lowest common multiples, remember, we just need to find all the common factors first, and then we list them and we see which is the highest. So we're going to do 12 and 15 to start with. So 12, remember, we've got 1 and the number itself. 2 goes into 12 6 times. 3 goes into 12 4 times. 4 would be the next number on the list, but we've already got it. So 1, 2, 3, 4, 6 and 12 are the factors of 12. We'll do the same for 15. So we've got 1 and 15, always start off with that line. Then 2 doesn't go into 15, so it's 3 next. 3 times 5 is 15. 4 doesn't go into 15, and 5 we've already got. So we stop because we've got them all. So it's 1, 3, 5 and 15. So if we look at both lists, we can circle the common factors. So that's 1. 2's not in both lists. 3's in both lists. 4's not. 6 isn't. 12 isn't. So that's all that sorted. So, oops, I forgot to circle the 3 there. So the common factors are 1 and 3. So the highest common factor is 3. So the common factors are 1 and 3, and the highest common factor is 3. We're going to do the same for 18 and 30 just now, and then you're going to have a go at some yourselves. Okay? So we're going to do 18 and 30. So we're going to find the HCF, the highest common factor. So to be able to do that, we have to go through the stages. We have to find the factors of each first, then the common factors, and then we can say what the highest common factor is. So, factors of 18, 1 and 18, 2 and 9, 3 and 6, not 4 and not 5, and then we've already got 6, so that's the factors of 18. 1, 2, 3, 6, 9 and 18. So we're going to find the factors of 30. So we've got 1 and 30, 2 and 15, 3 times 10 is 30, 4 doesn't go into 30, but 5 does, and it goes in 6 times. So we stop because we know we've got them all now. So 1, 2, 3, 5, 6, 10, 15 and 30. So if we look at the common factors now, the numbers that are in both lists, then we've got 1, 2, 3, 6 is in both lists, 5 isn't, 9 is not in both, 18 is not in both, and none of the others are. So our common factors are 1, 2, 3 and 6. So the highest common factor, the HCF, is just the biggest one in that list, so it's 6. Okay, so what I want you to do just now is pause the video and try and find these highest common factors. Now I'll make that small enough so you can see it, because I also want you to, move that along a bit, just a little bit, oh dear, there we are. If you get on really well with 1, 2 and 3 here, I want you to try the extension questions where you're finding the highest common factor of sets of numbers, not just pairs of numbers. So you will need to write down all the factors of 12, the factors of 30 and the factors of 42 find the common factors and find the highest one for that. So pause the video anyway, you get on with those and then come back and check your answers. So here are your answers. So you can see for each set what I've done is written the factors of each number, listed the factors, highlighted the common factors, and then written down what the highest common factor is. So take a moment, pause the video, check all your work. So that's all we wanted to do on common factors and highest common factors. And now what we're going on to is prime numbers. So you've possibly heard of prime numbers before. They're a special set of numbers, and we needed to learn about factors before we could do prime numbers because the word factor is in the definition of a prime number. So the definition of a prime number is this: a prime number has exactly 2 factors. So it doesn't mean 2 or 3 or 1 or 2, it means exactly 2. Okay? So another way of saying this is that you will only find a prime number in the 1 times table and its own times table. You won't find it in any other times tables, but it has to be in 2 different times tables. So we're going to look at the numbers from 1 to 20 and we're going to think about which ones of those are prime numbers by thinking about their factors. So, thinking about number 1, what multiplies together to make 1? Well, there's only one way of multiplying 2 whole numbers to get 1, isn't there? It's 1 times 1. So 1 actually only has 1 factor. It's 1. So 1 is not a prime number. Okay, because it doesn't have exactly 2 factors. Now, if we think about multiplying numbers together to make 2, well, 1 times 2 is 2, and there isn't another way of multiplying. So we've got 2 factors there, haven't we? 1 and 2. So 2 is a prime number. And 3, well, 3, you can multiply 1 times 3, or the other way around, but still you've only got 2 factors, haven't you? There's no other way of multiplying whole numbers to make 3. So 3 is a prime number. But what can we multiply together to make 4? Well, we know we've got 1 and 4, but also we've got 2 times 2, haven't we? So 2 times 2 is 4, and that means that 4 is not a prime number because it's got 3 factors, 1, 2 and 4. Okay? So I want you to take a couple of minutes just now, pause the video, go through the list of numbers from 1 to 20 and work out which ones are prime. You can discuss it with each other or somebody at home, or just come back in a minute for the answers. So, to put you out of your misery, the numbers that are prime from 1 to 20 are 5, not 6, because that's 2 times 3. 7's prime, 8's not, because it's 2 times 4. 9's not, 3 times 3. 10's not, 2 times 5. 11 is. 12's not. Remember, we've just looked at lists of factors of 12. 13 is. 14 is 2 times 7. 15 is 3 times 5. 16 is 2 times 8 and 4 times 4. 17's prime. 18 is 2 times 9 and 3 times 6. 19 is prime. And 20, again, we've just looked recently at factors of 20. You've got 2 and 10, 4 and 5. So 20 is not prime. So the prime numbers between 1 and 20 are 2, 3, 5, 7, 11, 13, 17 and 19. And there are things to notice about this set of numbers. Apart from 2, all the prime numbers are odd. And the reason for that is because, apart from 2, all the even numbers are in the 2 times table. So if they're in the 2 times table and they're not 2, then they're not prime. Okay? All the numbers that are in the 5 times table beyond 5. So all the multiples of 5 are not prime, apart from 5 itself. All the multiples of 10 are not prime, because for a start off, they're multiples of 5 anyway, aren't they? But they're also multiples of 10. So we can discount some of them and cross them off straight away. So the task that I want you to do now is pause the video and work out which of these numbers are prime numbers. So we've already covered one of them. Remember how to spot multiples of 2? We just talked about that briefly. Multiples of 2 are the even numbers, so they end in a 2, 4, 6, 8 or 0. Multiples of 3, you can add the digits together and test that way. Multiples of 5 end in a 5 or a 0. And again, multiples of 9 you can spot by adding the digits together and see if the answer is a multiple of 9. Okay, so take a few minutes, work through each of those numbers and see which ones are prime and which are not. Well, I hope you got this right. 23 and 37 are the only numbers of those that are prime, because all the rest are in other times tables apart from their own and the 1 times table. Right, job for you to do now. Again, pause the video and I want you to pick a set of numbers. So either pick A, B or C. C are more tricky. And I just want you to decide for each one in the list that you're doing, is the number prime? If it's not prime, say why it's not prime. Say which other times tables it's in. So for example, here, I haven't put 6 in any of the lists, but you would say 6 isn't prime because it's in the 2 and the 3 times tables. So pause the video just now, see if you can write down, just pick one of those lists, and out of the 4 numbers, write down which ones are prime, which ones are not, and if they're not, why they're not. So here are your answers. Again, pause, check your answers. Now, the last thing that I want us to look at is prime factors. Now, this is extension work, so if you are feeling like you've done well on the rest of it, then that's brilliant. Let's go and look at prime factors. If not, if you're thinking, I've only just managed to learn what we've done already, then don't worry about this just now. We can catch up with this another time. So, prime factors are combining what we've been learning. So they are factors and they are prime numbers. Okay, so for example, 10 we can make out of 2 times 5, can't we? And 2 and 5 are both prime numbers. Okay, now if we're listing prime factors, if we think about 20, if we list the factors of 20, here they are, and the ones out of that list that are prime are 2 and 5. But 2 times 5 is not 20, is it? So just writing down what factors are prime, yeah, it tells us how the number's made up. But what we want to look at is how you express a number as a product of its prime factors. And product means multiply together. So there's a special method for doing this that I'm going to show you just now. So what we do to express a number as a product, a multiplication of its prime factors, is we think about the number. So we're going to do 20 just now. And what we do is we think of our factors of 20. And particularly, we're just thinking about our prime numbers. So remember, I'll just write down the first few prime numbers. There you go, there's the ones that are less than 20 for us to refer to. So what we do is pick the first prime number, which is 2. Does 2 go into 20? Yes, it does. So we write 2 there and 20 there. Nope, we don't write 20 there at all because it's 2 times 10, silly Mrs. Finley. So 2 times 10 is 20. Now 2 is prime, so we're going to circle 2 and then we're going to look at 10. So we look at these lists of prime numbers again, and we start with 2. Does 2 go into 10? Yes, it does. So we split it up. 2 times 5. And 2 is prime, so we can circle it. 5 is also prime, so we circle it too. So what we've got here, we can just express, we can express 20 as a product of its prime factors, which means if we look at the circled numbers, what we've got is 2, 2 and 5. So what we can say is that 20 is equal to 2 times 2 times 5. And we can simplify that a little bit because we can write 2 times 2 as 2 squared times 5. So basically that's how we can multiply numbers together, prime numbers together, to make 20. So we're going to do the same with 30. So you always start, look and see if 2 goes into your number. So it does. 2 times 15 is 30. So we circle the 2 because it's prime. Then we look at 15. 15's not prime, so we know we need to continue. So 2 doesn't go into 15, but 3 does. So we're going to write down 3 and 5 now. And they're both prime, so we can circle them. So what we can say is that 30 is equal to 2 times 3 times 5. And that's the product of prime factors. Okay, next, 45 we're going to do. So thinking about our list that we can't see anymore, bring it down a bit, hold on, there we go. So 45, well, 2 doesn't go into 45, so we can't start with that. 3 does go into 45 because 4 add 5 is 9. That's in the 3 times table, so we know we can write down 3. Then we just need to work out that the partner of 3 is 15. So 3's prime, we can circle that. And look, we've already got 15 here. We know how to do 15. It's 3 and 5. So altogether, 45 is equal to, we've got 3 times 3 times 5. So remember, we can write that as 3 squared times 5. Okay, and then we're just going to do 24. So we're going to start off with 2, because 2 is a factor of 24. So 2 times 12, circle the 2 because it's prime. Then, does 2 go into 12? Well, it does. So 2 times 6 is 12. So we can circle the 2 because 2 is prime. Then we look again at 6. Does 2 go into 6? Yes, it does. So 2 times 3 is 6. And we can circle the 2 and the 3 because they're both prime. So what we've got for 24 is that 2 times 2 times 2 times 3. Because remember, we write down all the circled numbers. But we can write that more simply. 2 times 2 times 2 we can write as 2 cubed times 3. So 2 cubed here means 2 to the power 3, so that's 2 times 2 times 2. Okay, so what I want you to do just now is pause the video and do the same. Work out the prime factors of 12, 40 and 39 and write each number as a product of its prime factors. So you're wanting it to look like this or like this. Okay, so pause the video and do that. Come back and check your answers. So there's your answers to them all. So we've got 2 squared times 3 for 12, 2 cubed times 5 for 40, and 3 times 13 for 39. So well done for getting to the end of that. And where we're up to on our learning outcomes now is multiples, factors, common multiples, common factors, lowest common multiple, highest common factor, prime number, and prime factor. I can identify and list all of the above, and the last thing that we're going to need to look at is answering questions in context. Okay, so well done. You've learnt quite a lot in this topic so far, and you should be very proud of yourselves. And I'll see you soon. Bye.